let's go further with the idea of a dynamic model of schooling based on what we talked about in the previous video regarding how the Mincer earnings function might have some limitations, econometrically speaking. We've got our Mincer earnings function like we talked about in the previous video. And now let's think about what this is going to look like if we have a two-period dynamic model. We've talked about people choosing the amount of schooling in period 1 and whether or not they want to work in period 2. And now that we're allowing people to make choices, we need to quantify their preferences. We're going to do that by specifying two different utility functions. U sub 1 is going to be the first period utility function, and U sub 2 is going to be the second period utility function. And the arguments of these utility functions are some of the variables in our model, and we'll talk about that momentarily. But right now, we just have these two utility functions, and they don't really have any particular functional form yet. We just have different variables entering each of these functions. Just to walk through things, we can say that Z is some measure of family background. Maybe it's an indicator for if the student's parent graduated from college. C is going to be some measure of schooling costs. K is going to be the number of children in the household. When the person is an adult, that might affect how whether someone works or not, depending on if they have to provide for a child. And then these etas, eta 1 and eta 2, they're going to be unobservable preferences in the same way that epsilon is unobservables relating to the log wage. And then we can string these utility these utility functions together and then add them up with a discount factor in front of the second period utility function, and that becomes our lifetime utility function. And delta is a discount factor that just discounts the future by some amount, and it needs to be between 0 and 1. So these three equations, the Mincer earnings function plus the system of equations for the utilities plus this lifetime utility function, those are going to define our model. Now, this is still a very simple model. We haven't said anything about abilities or motivations or personality traits. We've said a little bit about a student's ability to pay for college, for schooling, but we haven't really said anything about much else. So there's plenty of ways that someone could nitpick this equation, but we're trying to keep it as simple as possible just to talk through the process. Now that we've written down the model and we know what the model entails, it can be helpful to classify the different components of the model into a common taxonomy, because that can help us think through what do we need to be able to find data on and what do we need to keep as an unobservable in the econometric framework. So roughly speaking, we've introduced all these different objects and how do they all fit together. Our model is treating as exogenous the family background, the schooling costs, and how many kids are in the household. What are the endogenous variables? Well, schooling is endogenous because that's something that the individual can choose, as well as the period 2 work decision. And then our outcome variable is the log hourly earnings, just like we had talked about with the Mincer earnings function. And then we have some unobservables in the model. These would be the epsilon and the etas. And then we have the actual model parameters that we're either going to want to estimate or find some way to calibrate. So these would be the betas, which would be the parameters in the Mincer earnings function, as well as the discount factor and any other parameters that we need for these f and g functions, which again, we haven't really specified fully, but they're sort of being placeholders at the moment. So that's our theoretical model that we have developed to try to understand the returns to schooling. And in the next video, we'll talk about practical specification issues that we might run into when trying to take this theoretical model to data.